A sequence is a list of numbers so something like 1, 2, 4 is a sequence just because it's a list. A series is a sum of that list. So as we move into the section on sequences and series, we're looking at lists and really trying to figure out if we can add them up. We're going to spend a lot of time talking about tests for convergence. And a way to think about that is, does this series have a sum we can find? Is there a finite sum? Or divergence? This series does not have a sum, or does not have a sum we can find. Someone might ask, well, what does it mean, does not have a sum we can find? Well, its sum may be infinity. It's not something we can find. It's not a real number. So, imagine with me, we had some notation. So this is called sigma notation. If you see this, it's just saying, it's just series notation. We're just adding a bunch of stuff up. And a lot of times they might say something like, from n, your book likes to use k, n equals 1 to infinity. And so this is just telling us that we're going to generate terms starting with the value of 1 for n, and then 2 for n, and 3 for n, so on and so forth, all the way to infinity. And there may be a rule that generates each of these things. So it could be something like, I don't know, 2 times 1/2 n. So this is the rule. That line won't be there normally, but this is the rule that generates every term. So notice, if we were to plug 1 into this, we end up with this, with 1, and plug 2 into this, and we end up with 1/2, and plug 3 into this, and we end up with 1/4. Right, and all we're doing is using our rule to generate our list. Now this same series could have been written as the sum of the series from n equals 0 to infinity of 1 times 1/2 to the n. And notice we get the same thing. 1 plus 1/2 plus 1/4, so on and so forth. And one of the points I'm trying to make here is that n does not refer to term number. N is just the value, the integer values you're using to generate your series. Many times it's 1, sometimes it's 0 out of convenience. And notice that the rules can be different. Right? So it may come down to the easiest way to express the rule for a problem, or it may come down to the easiest way that one sees to express a rule. This is really our focus, is based on things like this, can we determine if there is a sum or not? We're not necessarily concerned with finding the sum, but could there be one? Because where we're going with this is we ultimately want to be able to represent some series that is generated by a rule. We'd like to be able to generate this, represent this as some type of polynomial. Right, so I don't know, a1 x to the first plus a2x squared, so on and so forth. Because if we can represent a series as a polynomial, we're really good at evaluating and doing work with polynomials, because that's what we've been doing with derivatives and integrals and everything else. Polynomials are easy to work with. Series can be difficult, but if we can represent them this way, if the series converges and allows us to represent them as a sum, we can talk about it as a polynomial and apply our knowledge of calculus to it.